Electrical exposure levels refer to the magnitude and duration of electrical current that can flow through the human body. These levels are classified into three categories. Level I, also known as low voltage, involves a current of less than 5 milliamps. The duration is usually less than 1 second. The effects of level I exposure may include a tingling sensation or slight muscle contractions, but are generally not serious. Level II, or intermediate voltage, involves a current ranging from 5 to 50 milliamps. The duration remains less than 1 second. The effects of level II exposure can include muscle contractions, respiratory distress, and unconsciousness. Level III, categorized as high voltage, involves a current exceeding 50 milliamps. The duration of exposure at this level is variable. The effects of level III exposure are severe and can include burns, electrical shock, cardiac arrest, and even death. Different organizations provide specific guidelines for safe working practices based on these electrical exposure levels. The National Fire Protection Association, or NFPA, 7TE standard for electrical safety in the workplace, offers some examples. For level I exposures, no special protective equipment is typically required. For level II exposures, rubber insulating gloves and other appropriate personal protective equipment, or PPE, are necessary. For level III exposures, only qualified personnel should work on these hazards, as specialized PPE and specific work practices are required. It is important to note that these are general guidelines and may vary depending on specific circumstances and requirements. Always refer to the relevant safety standards and regulations for your jurisdiction. The amount of current that the human body can handle varies based on several factors, including the path of the current, the duration of the exposure, and the individual's physical condition. Even relatively low levels of current can be dangerous, particularly if the current passes through vital organs such as the heart or brain. Understanding the different electrical exposure levels and the associated risks is crucial for implementing appropriate safety measures in the workplace. Firstly, it is essential to identify and assess potential electrical hazards in the work area. This involves inspecting electrical equipment and systems for defects, ensuring proper grounding, and implementing lockout/tagout procedures to prevent accidental energization of equipment during maintenance or repair. Secondly, employees should receive comprehensive training on electrical safety practices, including the proper use of personal protective equipment, safe work procedures, and emergency response protocols. Training should be tailored to the specific electrical hazards present in the workplace and should be regularly updated to reflect changes in technology and regulations. Thirdly, personal protective equipment should be selected based on the specific electrical hazards to which employees may be exposed. This includes rubber insulating gloves, which provide protection against electric shock when working on or near energized equipment. Other types of PPE may include insulated tools, safety glasses or face shields, and flame-resistant clothing. Fourthly, safe work procedures should be established and followed to minimize the risk of electrical accidents. These procedures should include guidelines for working on or near energized equipment, using appropriate tools and equipment, and maintaining a safe distance from electrical hazards. Lockout/tagout procedures should be implemented to ensure that equipment is de-energized before maintenance or repair work is performed. Fifthly, regular inspections and maintenance of electrical equipment and systems are essential for preventing electrical hazards. This includes inspecting wiring, connections, and insulation for damage or deterioration, testing ground fault circuit interrupters, or GFCIs, to ensure they are functioning properly, and replacing worn or damaged equipment. Sixthly, emergency response protocols should be in place to address electrical accidents, such as electric shock or arc flash incidents. These protocols should include procedures for providing first aid to injured employees, contacting emergency services, and investigating the cause of the accident to prevent future occurrences. The National Electrical Code, or NEC, provides detailed requirements for electrical installations to ensure safety. Adhering to the NEC requirements is crucial for minimizing the risk of electrical hazards in buildings and other structures. Some key aspects of the NEC related to electrical safety include grounding, overcurrent protection, wiring methods, and equipment installation. Grounding is the process of providing a low impedance path for fault current to return to the source, which helps to prevent electric shock and equipment damage. The NEC specifies requirements for grounding electrodes, grounding conductors, and bonding to ensure that electrical systems are properly grounded. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or short circuit. The NEC specifies requirements for the selection and installation of overcurrent protection devices to protect wiring and equipment from damage. Wiring methods refer to the types of conductors and raceways used for electrical installations. The NEC specifies requirements for the selection and installation of wiring methods based on factors such as voltage, current, and environmental conditions. Equipment installation requirements cover a wide range of electrical equipment, including lighting fixtures, receptacles, switches, and appliances. The NEC specifies requirements for the installation of this equipment to ensure that it is properly supported, connected, and protected. Furthermore, the Occupational Safety and Health Administration, or OSHA, has regulations that address electrical safety in the workplace. Compliance with OSHA's electrical safety regulations is mandatory for employers in the United States. OSHA's electrical safety regulations cover a wide range of topics, including electrical safety-related work practices, electrical protective equipment, and electrical installations. Electrical safety-related work practices include procedures for working on or near energized equipment, using lockout/tagout procedures, and selecting and using appropriate personal protective equipment. Electrical protective equipment includes rubber insulating gloves, insulated tools, and other equipment designed to protect employees from electric shock and burns. The electrical installation requirements cover a wide range of topics, including grounding, wiring methods, and equipment installation. In addition to the NEC and OSHA regulations, there are other industry standards and best practices that can help to improve electrical safety. These standards and practices may be developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, the American National Standards Institute, or ANSI, and the National Safety Council, or NSC. These organizations offer guidance on various aspects of electrical safety, including equipment design, installation, and maintenance. Moreover, arc flash is a dangerous phenomenon that could occur when electrical equipment fails, resulting in a sudden release of energy. Arc flash incidents can cause severe burns, blindness, and even death. Arc flash hazards should be assessed and mitigated in the workplace through the use of arc-rated personal protective equipment, engineering controls, and administrative controls. Arc-rated PPE includes clothing and equipment that is designed to protect employees from the thermal effects of an arc flash. Engineering controls include measures such as installing arc flash barriers and using remote racking devices to reduce the risk of exposure to arc flash hazards. Administrative controls include procedures for working on or near energized equipment, such as de-energizing equipment before performing maintenance or repair work. In the event of an electrical accident, it is important to provide prompt and appropriate first aid. Electric shock can cause a variety of injuries, including burns, cardiac arrest, and respiratory arrest. First aid for electric shock victims should include ensuring that the power source is disconnected, assessing the victim's condition, and providing cardiopulmonary resuscitation, or CPR, if necessary. Burns should be treated with cool water and sterile dressings. The victim should be transported to a medical facility for further evaluation and treatment. Investigation of electrical accidents is crucial for identifying the root causes of the accident and preventing future occurrences. The investigation should include a review of the work procedures, equipment, and training involved in the accident. Corrective action should be implemented to address any deficiencies identified during the investigation. The Electrical Safety Foundation International, or ESFI, is a non-profit organization dedicated to promoting electrical safety. ESFI provides educational resources and training programs for consumers, workers, and electrical professionals. SB also conducts research on electrical safety issues and advocates for policies that promote electrical safety. Continuous improvement in electrical safety is essential for protecting workers and the public from electrical hazards. This involves staying up to date on the latest electrical safety standards and regulations, implementing effective safety programs, and continuously monitoring and evaluating safety performance. Remember to always energize electrical equipment before working on it, whenever possible. Use insulated tools and equipment when working on or near energized equipment. Wear appropriate personal protective equipment such as rubber insulating gloves and safety glasses. Maintain a safe distance from electrical hazards. Never work alone when performing electrical work. Be aware of your surroundings and potential electrical hazards. Report any electrical hazards or unsafe conditions to your supervisor. Participate in electrical safety training programs. Follow lockout/tagout procedures to prevent accidental energization of equipment. Inspect electrical equipment and systems regularly. Test ground fault circuit interrupters, or GFCIs, to ensure they are functioning properly. Use extension cords safely and do not overload circuits. Avoid using electrical equipment in wet or damp locations. Never tamper with electrical equipment or wiring. Call a qualified electrician for any electrical repairs or installations. By following these safety tips and guidelines, individuals can significantly reduce the risk of electrical accidents and injuries. Education and awareness are key to preventing electrical hazards. Be proactive in promoting electrical safety in the workplace and at home. Consider some additional specific scenarios and related safety measures. When working with electrical panels, always ensure that the panel is properly labeled and that you understand the circuit breaker configuration. Use a voltage tester to verify that the circuit is energized before working on it. Wear appropriate PPE such as rubber insulating gloves and safety glasses. When working on overhead power lines, maintain a safe distance from the lines and use appropriate tools and equipment. Never touch overhead power lines, even if they appear to be insulated. Call the utility company if you need to work near overhead power lines. When working with underground cables, use a cable locator to identify the location of the cables before digging. Dig carefully around underground cables to avoid damaging them. Call the utility company if you damage an underground cable. When working with portable generators, ensure that the generator is properly grounded and that it is located in a well-ventilated area. Never operate a generator indoors or in an enclosed space. Use a ground fault circuit interrupter, or GFCI, with portable generators to protect against electric shock. When working with batteries, wear appropriate PPE, such as safety glasses and gloves. Avoid contact with battery acid. Dispose of batteries properly. When working with lighting fixtures, ensure that the fixture is properly installed and that the wiring is in good condition. Use the correct type of bulb for the fixture. Avoid touching the bulb when it is hot. When working with appliances, read the manufacturer's instructions carefully before using the appliance. Use the appliance only for its intended purpose. Unplug the appliance when it is not in use. When working with electrical cords, inspect the cords regularly for damage. Replace any damaged cords. Do not overload electrical outlets or extension cords. Keep electrical cords away from water and heat. Consider the specific requirements for working with high voltage equipment. High voltage equipment requires specialized training and equipment. Only qualified personnel should work on high voltage equipment. Follow all safety procedures and guidelines when working with high voltage equipment. Understand the importance of proper grounding in electrical systems. Grounding provides a safe path for fault current to return to the source. Proper grounding helps to prevent electric shock and equipment damage. Ensure that all electrical equipment and systems are properly grounded. Learn about the different types of electrical hazards, including electric shock, arc flash, and electrical fires. Understand the causes of these hazards and how to prevent them. Be aware of the warning signs of electrical hazards. Stay informed about changes in electrical safety standards and regulations. The electrical industry is constantly evolving, and new standards and regulations are being developed to improve safety. Stay up to date on the latest changes in electrical safety standards and regulations. Participate in continuing education and training programs to enhance your knowledge and skills. Share your knowledge and experience with others. Promote electrical safety in your workplace and community. By working together, we can create a safer environment for everyone. Consider the impact of environmental factors on electrical safety. Environmental factors, such as moisture, temperature, and dust, can affect the performance of electrical equipment and increase the risk of electrical hazards. Take steps to protect electrical equipment from environmental factors. Implement a comprehensive electrical safety program in your workplace. A comprehensive electrical safety program should include policies, procedures, training, and equipment to protect employees from electrical hazards. The program should be tailored to the specific needs of your workplace. Regularly review and update your electrical safety program to ensure that it is effective. Encourage employee involvement in electrical safety. Employees should be encouraged to participate in electrical safety training programs and to report any electrical hazards or unsafe conditions. Create a culture of safety in your workplace. Ensure the correct use of portable electric tools. Portable electric tools need to be inspected before use to ensure the cord is not damaged. If there is damage to the cord, the tool should not be used, or it should be repaired by a qualified person. A ground fault circuit interrupter, or GFCI, should be used on the circuit. Ensure electrical equipment in hazardous locations is appropriately rated for the location. Certain locations may contain flammable vapors or dust, and any electrical equipment in that area must be rated to prevent an explosion. Ensure flexible electrical cords are not damaged. Flexible electrical cords must be protected from damage and cannot be run through doorways or windows or attached to building surfaces. They cannot be used as a substitute for fixed wiring. Understand the relationship between voltage and current. Voltage is the electrical potential difference between 2 points, while current is the flow of electrical charge. The higher the voltage, the greater the potential for current to flow. The amount of current that flows depends on the voltage and the resistance of the circuit. Ohm's law describes the relationship between voltage, current, and resistance. The formula is voltage equals current times resistance. Understand the concept of electrical resistance. Electrical resistance is the opposition to the flow of electric current. The higher the resistance, the less current will flow for a given voltage. Resistance is measured in ohms. Materials with low resistance are called conductors, while materials with high resistance are called insulators. Understand the concept of electrical power. Electrical power is the rate at which electrical energy is transferred. Power is measured in watts. The formula for power is power equals voltage times current. Electrical energy is measured in kilowatt-hours. 1 kilowatt-hour is the amount of energy used by a 1000-watt device operating for 1 hour. Understand the concept of electrical circuits. An electrical circuit is a closed loop that allows electric current to flow. A simple circuit consists of a voltage source, a conductor, and a load. The load is the device that consumes electrical energy. There are two main types of circuit: series circuits and parallel circuits. In a series circuit, the current flows through all of the components in the circuit in a single path. In a parallel circuit, the current has multiple paths to flow through.